So what we want to focus on today, hopefully, we can sort it by the end of the period. I want us to be able to solve the exponential and log functions today. So we take it one by one because they're kind of connected. Because we all know that exponential function can be changed into log function and vice versa. And for the exponential function, for your syllabus, especially because you're HL, you are dealing with different cases of exponential. The case of exponential E, something like this. And you're also dealing with when you have any other number. For example, in this, you'll be given something like exponential x, exponential sine x, and so on like that. But in these cases, we might be interested in 2 raised to power cos x. How do we differentiate such a function? Of course, such a function can always be put into decimals. We can know what the graph looks like. And once we know what the graph looks like, we can find the gradient at a point, right? But is there a way we can find a gradient function at any point so that when the point is given, we can always find what the derivative will be? Do you understand what I mean? So there will be 2 categories of exponential to be discussed. Similarly, in logarithm, we will discuss natural logarithm. Okay? By x, maybe I just say f of x because it could be anything. Okay? And also we will discuss logarithm to any other base. So there are 4 different things we are trying to look at. Am I making sense? So let's begin with the exponential. I tried to arrange it in that order on my decks this morning. Let's begin with the exponential. I would say derivative of e to power f of x and a to power f of x. Please pay attention. For e to power f of x, let's look at it this way. There are different ways to look at it. I think you can use the first principle. And also you can use the Maclaurin series, but you haven't done Maclaurin series. But you don't have to worry about it. It's in your booklet. Even what I'm about to establish is in your booklet. So that's why I brought these 3, 1 for each table. So you can look at the second to the last page. Okay, come together and look at the second to the last page. You see where HL, SL, topic 5 is. Okay? So, did you see topic 5? Derivative of exponential. Then look at something called Maclaurin series. Have you seen Maclaurin series? It should be in the last part. Did you see the expansion of exponential x? 1 plus x squared over 2 factorial, x cubed over 3 factorial, and so on. We can also use that to derive what I'm about to talk about. So let's close that and focus on the board. For f of x equals, I call it raised to power f of x. I don't want to use f of x. But I can change this to g of x. It doesn't have to be f of x. It's just that we're used to f of x. Maybe exponential x. We'll focus on exponential x. Then we'll use a chain rule to extend it to any other thing. That's why chain rule, product rule, and quotient rule are very important. Okay? So for this, the derivative, do you remember? It's limits as h tends to 0 of what? G, divided by, so that will have been limits as h tends to 0, and you guys see? That will be exponential what? X plus h, exponential x divided by h, right? Which would have been limit, I'm trying to save the space. exponential x, exponential h, exponential x. Can you see that? Such that this is limit h tends to 0, exponential x bracket exponential h minus 1 divided by h. Yes? You can break it into two limits. Limits h tends to 0 of exponential x, limits exponential h minus 1 divided by h as h tends to 0. Can you see? What is this one? Limit of exponential x as h tends to 0 is going to be what? Say that again? Nope. Say that louder, louder. Exponential x. Why is that, Clarissa? You need to speak louder. I don't know, maybe it's this AC. I can't hardly hear anyone. I'm going to turn it off for now.
Because it's a constant.
Do you need the aircon, sir? Mr. Do you need it? So noisy, I can't hear them. You say, why is that?
Because it's a constant.
Because it looks like a constant. We are not saying it's a constant, but the variable is not here. Okay? I think I heard you guys saying the same thing. I just wanted to hear from her. Okay? But for this one, can you maybe go to your decimals or whatever, plot the graph of exponential h minus 1. You can use your calculator. I'm sure you have your graphic display calculator. Exponential h minus 1. Or is there a way to reduce the noise for this thing so that you guys will not be odd? So it's too noisy. I'll try to raise my voice though. Oh, can you see? So the graph should look like this. Such that the intercept is what? Check. Should have something like that. Is that what you got? So you could see that as h tends to 0, that function tends to what from either side? Say that again. 1. That's the graph of that function. Okay? So as h tends to 0, so which means the second part is what? 1. So what we are saying in essence is the derivative is exponential x again. Okay? Another way to visualize this, or to look at this, from your expansion of exponential x, which you have seen in the formula booklet. Okay? And it continues indefinitely. Finding the derivative of exponential x is the same as finding the derivative of everything here, which will be 0, 1, right? 2x over 2 factorial, which is 2. 3x squared over 3 factorial, which is 6. 3x squared, right? 4x cubed over 24, and it continues. So this will be 1 plus x. This is going to be x squared over 2. This is going to be x squared over 6, and so on. So which is, again, 2 is 2 factorial. 6 is 3 factorial. So you are back to the same function. Does it make sense? So that was why I told you the story of yesterday. Okay? And I'll say it again, especially because of Brandon. Somebody told me that story, I don't know how many years ago. Early 2000, I think. Yeah, early 2000. 2003, I think precisely. Maybe that's not the way you put it, but this is my understanding of it. So let's pretend there's a village, and the occupant of that village are functions. Just like people that are living here are human beings. If you go to the zoo, you see the animals. So in this particular region, the occupants are functions. An outsider comes in, terrorizing everybody, telling them he is able to differentiate them and is able to integrate them. I guess the monster come from the city of Calculus to invade them. We can put it that way. Everyone is running. All the functions. F1, run away. F2, run away. G1, G2, Gn. Everybody's running away. Because maybe their ancestors have told them, once you get differentiated, your life will never remain the same. Once you get integrated, you will change from the way you are. Maybe the change is that some beauty product will be applied on you and you look more beautiful. Maybe the change is that your body will be lit on fire and you're going to be in pain for life. But nobody's willing to take the risk. Everybody just wants to just leave me the way I am. Because I don't know if this change is going to be beneficial to me or disastrous to my life. So everybody runs for their life. Then the monster guy from the Calculus city saw somebody standing, not moving. And of course, you feel like, who is challenging my authority here? I'm supposed to be terrorizing people. I said, but I said I'll differentiate you. Then, oh yeah, I heard you. I said I'll integrate you. I heard you. Then of course, you'll be curious to wonder, who is this person not afraid of me? So my name is Exponential X. So basically, indirectly saying, everybody can run for their lives. If you differentiate me, I do not change. If you integrate me, I do not change. So why should I even run for you? So, and that makes me remember this since that time, since somebody introduced this story. Maybe not the way he put it, but you know, that is how I remember it. So, always remember that the derivative of exponential x, also in integration, we will say that the integral of exponential x does not change. Now, when we say exponential x, we do not mean e to the power minus x. That is not exponential x. That is exponential negative x. So do not do the remix version. No, just leave the song the way it is. Don't put the cover now. Okay, now let's come here. If you have other, you have like a composite now. If y is exponential, maybe u, where u is a function of x, then we will apply the chain rule by saying that, oh, let's say if y is exponential f of x now, okay? So we say let u be exponential, let u be the function of x, which is not ordinary x in this case, okay? So that y will be exponential u. Of course, from here you can find the u dx, which is your f dash of x. And from here you can find the y du. What is the y du? Come on, that shouldn't take time. What is the y du?
Exponential f of x.
Exponential?
F of x.
Really, dude? What has f of x got to do with this? What is the y du? Exponential u. What are you saying? When you differentiate f of exponential x, it doesn't change. When I say differentiate here, I mean with respect to x. Everybody, I believe, knows that. So now we are differentiating with respect to u. That's exponential u. If I give you exponential theta, and I differentiate with respect to theta, what is the result? Okay? So you can apply the chain rule. Okay? By chain rule, dy by dx, because y is originally a function of x, we apply the chain rule. Okay? It's equal to dy du times du dx, and dy du is exponential u, du dx is that. So, and if you put it back, you have exponential f of x times f dash of x. What does this mean? It means to differentiate an exponential function with base e, all you have to do is copy and paste the function back and multiply by the derivative of the power. That's the easiest way to understand it. If you have exponential with base e, copy and paste the function given the way it is first, then multiply by derivative of the power. Okay? And of course, this you don't need to memorize because it's in your formula booklet. Okay? So, now, that is for when I'm done with the other one, which is exponent a raised to power something, we'll write like a summary, and then we'll work on that before we go to logarithmic function. I want us to really work on this first. Now, we might be interested in the base not being e. For maybe g of x is equal to a to power x. Let's sort a to this first. Once we are able to sort this, we can sort a to power f of x by using what? Chain rule again. Am I making sense? So let's sort this first. This, we do not need to apply this technique. And we cannot use this because Maclaurin series does not say the same thing works for any base. This is specifically for exponential x. Does that make sense? So forget about this. Well, you might try to use this. Okay, maybe it will work. You can test it. You're going to end up having this a raised to power h minus 1 divided by h. Look at what the graph looks like. Just maybe. Okay. But the easiest way to look at it is to apply the law of logarithm. Do you guys remember this law? A to power log a x is equal to x. Do you remember this? Once the base of the index is the same as the base of the log, automatically you are left with this one. We proved it in Form 5. I remember it was one of the class activity. After some time, then I proved it for you. Okay. Do you remember this law? Are you sure? You look like, no, I don't remember, but I'll go and study it later.
I remember.
Okay. So that we will use here. If this is g of x, it is safe to write a to power logarithm to base a of x. No. No. If I need my x directly on it, I need only x, right? So I'm going to end up putting this. No. I need x as the top. I don't want to do a. That would be too much. Okay, there's an easy way to go about it. No, I don't need that law. Let my g of x be changed to y for easy stuff. Then I can have y equals a to power x. Okay? Now let me take the logarithm to base e of both sides. But if I take the logarithm of base e to both sides, we haven't done the derivative of logarithm. Nah. So that method won't work again. Sorry. There are different ways you can approach it, so that is why I thought of that. Okay, I think I still have to go back to this log. What am I missing? So if I want to change it to this log form, then now we have, I can use exponent. I already know about exponent now. And I can have ln, which is logarithm to base e of a to power x. Would this work? E, just like this law. Then whatever that is here comes down. So what is here? So I use the law of logarithm. So the reason I use this is because according to law of logarithm, let's say m log to base m of n must give n back. Okay? So clearly, because this is logarithm, this is a log, right? And there's a power. The power can be at the back. Alright? So clearly, my g of x is simply exponential x ln a. Do you agree? Then I can apply what I've done here. So my g prime of x will be, what did we agree on? Copy and paste first, then differentiate the power. Copy and paste first means exponential x ln a. Differentiate the power means differentiate x ln a with respect to x. So what is that? It will be x, no, derivative of x times ln a. Ln a is the constant, right? So ln a will be a constant, then times 1, which is derivative of x. Do you understand that? So, but this you can use the logarithm law to take it back again, such that this is exponential ln a to power x times ln a. Can you see that? Such that this can cancel now. So you are left with what? A to power x ln a. Can you see that? So if you are differentiating a number to power x, you copy and paste, but the next thing is to take the natural log of the base. Does that make sense? And the same, we just extend it by chain rule. This does not need to be memorized. I'm only bringing these tricks of manipulation. It might help you in some other stuff that you want to do. So if y happens to be exponential f of x now, so we say let u be f of x such that y is a to power u. I shouldn't have called this exponential. Okay? So from here I can find the u dx, which is f prime x, right? Here I can find the y du. The y du using this. So what is it? Talk to me. Louder, please. A to power u ln a or log a. But when you say log a, I don't want you to see it as log base 10. That's why I like to use the ln. So I just call it ln. It's not like that's what everybody calls it anyway. Okay, so quickly by chain rule, dy by dx is dy du times du dx. So dy du is a to power u ln a times what? F prime of x. So what does that mean? It's just an extension. So it means when you copy and paste, you take the natural log, then you find the derivative of the power. Does that make sense? So in summary, we have the following. Let's write. I'll write the summary, then we'll take examples. Mr. Chang is sleeping. Well, he told me he might be sleeping class today. Why are these things not used? I don't think we can see very well. Is this better on the video? Let's try it quickly. take notes quickly. Again, no one will expect you to prove. The only reason I showed you is and there are different ways that people might come up with the derivatives. So the only reason I mention it is so you learn some way to reason. For example, oh, this log, oh, if I'm trying to do something, I could reason like this. And you could see some of the ones I tried to do that didn't work out. So you learn to try new things if something doesn't work out, and so on and so forth. So this will be posted online if somebody needs it later. What? Sorry. Maybe I posted a WeChat. You can use. Oh no. I forgot we have a slow baby in the class. But also, I don't want you guys to spend so much time copying. Alright. Sending now. Hopefully I still have some data. Yeah. So I'll post questions, so please start immediately. When you do this, you don't have to say chain rule, let u be something something. You can just follow this. Alright? You don't have to go to chain rule. It's allowed to go directly. So I expect a one-line solution or 2 max. Okay?